Hey chemistry students, and welcome to your tutorial on drawing orbital diagrams. We're going to work through two different examples today where we're asked to draw the orbital diagrams for nitrogen and sulfur. So our first step in doing this is to figure out the electron configuration. So for help with that, please see the electron configuration video. I'm going to use the alpha chart to give me my electron configuration for both nitrogen and sulfur. So nitrogen has 7 electrons. So nitrogen's electron configuration is 1s2, 2s2, 2p3. Now when I'm doing an orbital diagram, I'm going to remember that s sublevels only have one orbital. So if it has one orbital, it only gets one box. I'm going to at least get my boxes first. So I have another S. I'm going to draw another box. P sublevels, because they can have a maximum of 6 electrons and only 2 electrons per orbital. P sublevels have 3 orbitals, or I'm going to put 3 boxes. Now I'm going to utilize Hund's rule and the Pauli exclusion rule as I fill up the electrons in my orbital diagram. So remember, Pauli exclusion rule states that you can have no more than 2 electrons per orbital and they must have opposite spins. Hund's rule states that electrons in an orbital, let's say of like P, D, and F, where there's more than one orbital in that sublevel, they will enter an orbital by themselves first before they will pair up. All right, so I'm going to start, and I'm going to show my electrons with arrows. So 1s2, got one arrow going up, having an upward spin, the other going downward. You can actually draw arrows either way. 2s2, I'm going to fill it up with 2 arrows for my electrons, showing that they have opposite spins. Now for 2p3, I have to remember Hund's rule, that electrons will enter orbitals by themselves first before pairing up. So I'm going to put an electron in each orbital, and I don't have any more electrons, so all 3 of these electrons will be unpaired. So 3 unpaired electrons. I'm just going to make a mental note of that. Alright, so I'm going to go on to the second problem. Sulfur has 16 electrons. Remember, you find that based on the atomic number. And it has an electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p4. Now I'm going to start my orbital diagram. So remember, S is designated with one box to show one orbital for S. Maybe I'll write that over the side. 1, P equals 3, D equals 5, and F is made up of 7 orbitals. So we show that with our box numbers. So I'm going to start. 1s2 gets one box. It has 2 electrons in it, so I'm going to fill it up. 2s2, 2 electrons, each have opposite spins. 2p6, there's 6 electrons total, but remember they're going to try and fight for their own spot first before pairing up and having opposite spins. 3s2, 2 electrons with opposite spins, and 3p4. So I have to remember Hund's rule. An electron will fill each orbital within that sublevel first before pairing up. So I have 1, 2, 3, but my electron configuration ends in 4. So this first orbital is going to have 2 electrons in it, meaning that I have 2 unpaired electrons left. Oftentimes you'll have questions about that, and that's when you can revert to orbital diagrams or just simply looking at the electron configuration and remembering how many orbitals and the max number of electrons could be within that sublevel. Try some more of these out on your own. Please ask questions and keep practicing. Thank you for stopping by.